Hi everyone. Today we will discuss about how to run radar simulation with HFSS. So the radar simulation, you already know radars are using for detecting the target and its distance, velocity, angle of arrival, and many other things. So we will see how to do that such simulation. First of all, you need to import uh, the CAD model into HFSS. For that, you can go to GrabCAD. There is a free CADs are available. So I imported a representative model of a fighter aircraft into HFSS. So you can just import here and import any kind of files directly into HFSS. And note that I used SBR plus simulation, so radar simulation is better to run with SBR. So change here with SBR plus, and uh, so I imported SCL files into HFSS and assigned the material property as PEC. So you can assign different material property, and once you assign it, you just have to select the control A, select all the models, right click, create a 3D component, and it will pop up a window, something like that. You can say this is my fighter, okay, fighter aircraft, something. So put some name and save it somewhere, wherever you want. So I'll explain you how to import it, so you can save it wherever you want to save. After that, what you can do is so first thing is will be importing or creating the model inside SBR plus and exporting as a 3D component. After that, what you need to do is insert a design, and over here there is a uh, option. So make sure you are converting this into SPR plus solution type and click OK. Now you can see this become SPR plus solution type. Better to change the unit so that instead of we can use meter. Okay. So zoom out. Now I wanted to create some path. So my one of the fighter aircraft will go something like this. Another aircraft will go something like this. Okay. For that, what you can do is create a spline. Okay. And just zoom out a little bit so that we can cover at least 1 kilometer to 2 kilometer area. So this area probably equivalent to 2 kilometer by 2 kilometer area. What you need to do is select this spline and click it here, click it here, click it like this. So this will be the path for an aircraft to fly. Okay. So I'm just clicking something like this. So I will fly my aircraft like this, and I will keep another aircraft which will fly from this point to this point. So you need to first click at the initial location, then goes to the other point. Okay. So in the second point, what we'll do is we'll click here and click something like here, and yeah, I can make this kind of a path also. Okay. And make sure you can, if you want to create a line, this movement will be in 3D, and if you want to be in 2D, right click over here, you can select the movement mode. Okay, I can select in plane so that my line will be creating in a single plane. So I can create something like this and double click it to finish it. Once you click that one, next thing is you need to create the body over here. For that, go over here into view, open this ACD extension tab. ACD extension means Ansys custom toolkit. So once it open, it will look something like like this. Okay, you can click on manage extension. Over here, if you click, you will see there is no toolkit called move it. It actually, you will get it from Ansys support. They have this toolkit. Some of the free toolkits are available. If you click on Ansys App Store, it will go, and you can see a lot of free toolkits are there. There are some toolkits which are paidable. So you can select which kind of application you are looking for. Electronics, then you can see multiple toolkits which are comes free with from you can freely download it. So once you go into Ansys application, if you are getting some toolkit downloaded, there is an option to install it over here. Okay, so if you click open, what it will do is it will direct you to some location. So just click over here and paste some. Okay, I think I need to go over here. So my location somewhere here, academic, and I can see the radar simulation. So we can see the app over here. So if you click it, this app will get installed. Okay, and once you install it, what you need to do is go to launch wizard. You can see the move it operation. So this is our design is HFSS design 2. What you need to do is you just have to select the project. So the project name is radar simulation. So in that we need to select design 2. It will automatically detect that 2 polyline. Okay, you can select the polyline. You can set the speed of your aircraft. One is 100 meters per second, and if you want acceleration or deceleration, you can set it over here. If you want some delay to start the 3D thing, you can set it. So you can also see the import component for path. So click over here, it will ask you where to browse that file. So if you go here, you can go to the same location. I may get some locations here. Okay. Yeah. So here I have a fighter aircraft 3D component. I can just click open and generate movement. So if you click it, it will automatically create the movement for that particular aircraft. Okay. Over here you will be able to see the aircraft is placed at the beginning. So in order to fly the aircraft through this path, you need to rotate the aircraft. For rotating, there will be a rotate axis. So just click over here, it will select it, then select the 3D component and rotate it. So rotate it for I think long 90 will be should work. Yeah, so you can see this aircraft is placed, and similarly you can open that toolkit one more time and select the polyline 2 and say my second fighter is flying at 150 meters per second, and select the 3D component. So we can see the 3D component with the radar is another 3D component. Place it and generate a move operation. Click on the move operations. So you'll be able to see another 3D component going to place it at these locations. Okay, I think it's still working. So you can customize your flight path and all the movement and specify your speed. You can edit it later also. Okay, once you placed it, we can close this one and check how it is coming. So for this one, the polyline 2, you can select it and rotate in the 5. Okay, select this guy and rotate it along, and it should be fine. Now you can see these 2 are placed. Okay, and one more thing you can notice over here is you select it, all the variables which are corresponding to the fighter aircraft 1 and 2 are here. So you can change, if you want to change the speed of the aircraft, you can change it. Acceleration, if you want to change it, you can do that. The time, you can change it. So the t is equal to 0 seconds. This is a scenario starting point. So I want to see if the aircrafts are moving as per the speed, which are 150. I want to see at 3 seconds where the locations are, and you just update it. Immediately you will see the fighter aircraft will update their positions. It's initializing the visualization. Since we are modeling like a 3 to 4 kilometer by 4 kilometer area, visualization will be a challenge. So you can see the fighter it actually moved from this point to this point. Okay, some rendering issues, that's why still you see one copy, but I'll show you some animations how the path going to be. So you can see the this is moved to this particular location, so we can visualize how the movement going to be. Okay, so this is your global coordinate and your fighter will move in these directions. Next thing is, once you place your aircraft, we need to place the antenna which is using for this aircraft to detect the other one. So you will have a transmitting antenna and receiving antenna. For that, select this coordinate, make sure the radar, wherever the radar going to place, you place at that point, and right click over here. There is an option called create antenna. So you can, if you have a measure data, you can import that measure data. If you already have a antenna pattern in another HFSS model, you can import that as near field or far field, or else you can use there are different types of antenna, built-in antennas are available. So if the designs are already available in some HFSS design, you can import it that automatically as a near field or far field. Otherwise, we have a lot of customized antennas, so you can see a lot of ideal antennas are there. So in this one, I can use this parametric beam antenna. Here I will say the antenna going to have a horizontal beam width of 60 degree, vertical beam width of, let's say, 20 degree, and it will automatically create that antenna over here. So if you click next, finish, you will be able to see the antenna which is going to place at this particular coordinate. Okay, so you can see the antenna is placed, and the antenna, probably if you want to rotate it, you can do the rotation operation also. Otherwise, you have second option is to change the beam pattern. Okay, so if you expand it over here, you have option to edit it again, and you can say vertical. Okay, it actually what happened is better to rotate the antenna. So vertically, horizontally it's not positioned well, so you can just place it and select this beam and rotate it along x by 90 degree. That will fix the problem. Okay, yeah, this is fine. And okay, there are some rendering issue, so you have to keep little further from the CAD. Okay, just for, let's say, I'm going to keep this one by 5 centimeter, because the CAD should not touch. It can be like lambda by 100 distance. You can keep something like a 0.05 mm, that will be 5 centimeter. Even that is also, you can still keep very, very close. Now you can see this pattern is placed. If you see, virtually it won't make any issue, and we can keep this one and create an instance of that same thing, same beam. So one will act like a transmitting antenna, and the second one will act like a receiving antenna. Okay, so this antenna also we need to move a little bit towards front. So we can keep 0, then 0.05 mm. So I'm assuming same antenna I'm going to use for as a transmitter and receiver. Okay. So the transmitter receiving antennas are ready. You can go over here under the excitation. You can set you can set right click over here. You can set the select TXRX. So assign one as transmitter, another as receiver, so that it will reduce the computation time a lot. And now we are good to go for simulation. Okay, Second thing is the setup. So the modeling setups are already. Then you need to go to add solution setup. Under the HFSS you can say range Doppler simulation, where first you need to assign a time variable. So with respect to time, you probably able to see what will be the uh, velocity and other thing. For that, every radar will have some specification, something like what is the center frequency of that radar, what kind of resolution this radar going to have, like 2 meter, what is the maximum range the radar going to have, like 5 kilometer. So you can change it over here, 5 kilometer, and velocity resolutions, and minimum velocity, let's put minus 25 meter per second, and the maximum velocity as 175 meter per second. Why? Because if one flight is going in this direction, another is coming in the opposite direction, the relative velocity will be like 50 plus 100. So this is a 100 velocity per 100 meter per second, and this one will be 50. So it will add together. So the effective velocity, relative velocity will be close to 150. That's the reason we took a 175 as a maximum, and minus 25 can also come, because if the target is moving in the opposite directions, or is going in the away from the radar, there can be negative Doppler also can create it. It also automatically determine what should be the bandwidth for such specification, how many frequency samples you need to take it, and what will be the coherent processing intervals. Everything it will automatically calculate. Setups are already. Now I wanted to simulate some scenario. I wanted to simulate scenario for you can say I can add a parametric variable. I say the time variable, I want to simulate it from 0 to all the way to 10 seconds with a 0.5 seconds interval. I can just click OK and click finish it, and then right click. I have an option to animate the scenario. I can do the animations. Okay, click OK. I will show you some image which I already took it. So this is a particular image. So you can see the one aircraft is moving, another one is flying. This is coming at very high speed, and it is taking some path. So this is a scenario which we are going to simulate it, and we already set up all the things. Then what we'll do is okay, so the visualization you can still control it. So if you want to change the beam radiation pattern size, you can put scaling factor like 500, so that you will be able to visualize the pattern, how it will look like in the scenario. So this is a similar scenario which we modeled in HFSS. You can see the fighter aircrafts and the opposite aircraft over here, and what we did is we ran the simulation for 0 to 10 seconds, and you can also visualize, check the simulation profile. So it completed within like one frame. It may be taking 7 minutes to create it, so multiple frames are there. Depends on the system, you can get a high speed up. So what you are going to see here is this is the velocity and this is a range. So you are detected at with respect to time, you will be able to see it. So what you are seeing is you are detected a target at close to 150 meter and at a distance about close to 1.5 kilometer away from this transmitting radar. Okay, and why it is not exactly 150? You will see that it's not a line of sight. The target is coming at some angle, so the actual velocity will have a cos alpha times comes in. So when it is comes towards normal to this particular radar, it will have exact 150. You have some angle, you will see the velocity variations. Okay, and how to plot this result? You have a right click on the result, you will see range Doppler plot. You can see range, velocity and range information, selecting dB, and you can also select which time you wanted to plot it over here. So I plotted it for just for 0 seconds. So we can do animations. Once you plot it, what you need to do is right click and do the okay, Once you plot it, you have option to show in modular window or not. Right click and check it, and if you check one more time, you can see it will get visible here, okay, along with the scenario. And if you want to animate the screen, just go to same setup, right click over here and animate it. So since this is usually used to take time, I already did the animation and exported as a file, like video. I'll show you that. So this is a video which I recorded from the export option. So you can see as the time goes, you can see the fighter is moving, and both radar also moving. And on the right side, this velocity, you can see it is coming like 150 when it's taking a turn, and when the cos theta times comes, the velocity is reducing drastically, and you can see at some point the velocity is going in the negative directions, okay. So it will depends on the scenario which you are simulating. It will exactly calculating what will be the distance and what will be the velocity. So you can see that earlier it was detected at 1.5 kilometer. Now it's very close to, at some point it's very close to, like say 200-300 meter away, and this will calculate automatically. Hope you understood how to do the radar simulation with the process.